Micromem is a company that has spent the last 10 years in the research and development of MRAM, which is magnetic random access memory. We developed at the University of Toronto, and we believe we've got a product now that will be the new memory product for all applications electronic-based.
The Hall sensor technology has been around since 1779. It's an old technology. To explain it in layman's terms, it's a cross, and anytime a magnetic field hits it, it will measure. It basically picks it up. So in reality, our memory is a Hall sensor with a little stack of iron on top of it with wires connected to it. And depending on which way the magnetic field goes in terms of a 0 and 1, it is stored in there, and the Hall sensor determines whether it's a 0 and 1 for memory, because you know all memories are zeros and ones. In our Hall sensor design, we're going to use that to our advantage. For example, you've heard of cameras, LCT cameras. We all have 10 or 12 megapixel type cameras where it takes high resolution pictures. Think for a moment if you replace that picture with an array of Hall sensors, so that when I take your picture, I'll get a magnetic picture. And what's happening is the camera's sending out magnetic energy, it's coming back in, and that sensor is picking up the directionality of that particular picture. So again, if you have a magnetic aura about you, or if you're a sample, or it's your blood, all these type of things that are capable of having a signature, basically the magnetic energy is hitting the Hall sensor, and at very, very low levels, we're able to detect that. The reason this is a significant trend for us is that prior to this, the sensitivity wasn't there.
The stage we're at today is commercialization, and we're using foundries, one based in California and BAE Systems based in Nashua, New Hampshire. Those two foundries are going to assist us in producing this product at a commercial grade level. So we've now left the lab and are now ready for actual product development.
The main differentiators of the Micromem Hall sensor are really three things. One, size. Everybody else on the market, these things are huge relative to ours. We've perfected a way through our patents to make these things, almost to the limit of the lithographic limits of the semiconductor foundries. As the foundries are able to make smaller and smaller things, our Hall sensors follow in that trend. So size is key. Secondly, sensitivity. What we found is that most of our competitors have to have an operation or amplifier on, or some device external to it, to pump up the volume, so to speak, so that you get the same sensitivity. Well, that's cost. And the third thing that we've got going for us is extremely cost effective. On a typical wafer, you can get 64,000 of these things. So these hardly don't have a cost associated with them, and as a result of it, you can start thinking about arraying them into a camera or putting millions of them in the water to watch for submarines. So it's a combination of size, performance, and cost.
Micromem has reached that point. It stepped out of the research phase and now moved into the position where it can start to deliver product. We have got a product that is so capable. We are now talking to companies regarding unmet needs and the realities of what they require from a technology that only we can supply.